Good morning, children. I am your Jagadish Master. Welcome to the physics online classes. Children, we will have our usual prayer. Please close your eyes. Hear your child. Now, O Lord, as I fold my hand in prayer, bless my parents and teachers. Keep us on your love and care. Help me to be kind to others, happy in my study and play. Give me your strength to conquer any wrong that comes on this day. Thank you, God. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. So, in this class, we will study about valency, my dear children. Okay. What is valency of an element? In chemistry, valency of an element is the measure of its combining capacity with other atoms when it forms chemical compounds or molecules. Okay, na? Best example is H2O, HCl, and etc. Children, once again I am repeating here definition of valency, that is combining capacity of an element with the other atoms. See here, a hydrogen is being combined with oxygen, and similarly hydrogen is also combined with chlorine. Like this, the combining capacity of an element, not only hydrogen, any element, an element I am telling, one element is being combined with the other element. Okay, now in order to understand this valency, we need to know Bohr's model of atom. Okay, now see, this is nucleus. Around the nucleus there are many orbits. Okay, like this. All these orbits are designated as K, L, M, N, or else you can say first orbit n equal to 1, n equal to 2. That means if second orbit, if we are talking about second orbit, n equal to 2. If third orbit, n equal to 3. How many electrons are there in each orbit? 2n square. Okay, in each orbit 2n square electrons are there. Take the example of first orbit. First orbit means k shell, that is n equal to 1. Okay, na? In first orbit means n equal to 1. See, 2 into 1 square, you will get 2 electrons. Okay, na? What about second shell or second orbit? N equal to 2. 2 square means 4. 4 2s are 8. 8 electrons are there in the second orbit. What about third shell? 2 into 3 square. Okay, na? 2 into 3 square, that means 9 electrons. 9 2s are 18 electrons are there. So see here, 2 into 3 square, in third shell you will have 18 electrons. What about fourth shell? 2 into 4 square, that is 16 into 2 into 16, 32 electrons are there. Now here I took some elements for the explanation of this Bohr's model. And electrons, how many electrons? See, these electrons are decided based on the atomic number. So hydrogen atomic number is 1 and number of electrons in hydrogen is 1. Okay, now take the nucleus and distribute that 1 electron in the 1 electron of hydrogen atom on the first orbit, in the first orbit. So but actually how many electrons should be there in the first orbit according to the Bohr's model? 2 electrons. But how many are there for hydrogen? Only 1. That means one electron is vacant or valency. So valency of hydrogen is 1. What about helium? 2. Atomic number of helium is 2. That means 2 electrons are there. Distribute this. Now how is it satisfied the condition 2n square? Yes. 2 electrons in the first orbit. That means 0 valency. Okay, now 0 valency for the helium. What about lithium? Lithium atomic number is 3. That means 3 electrons are there. Now distribute this. Okay, first orbit, in the first orbit you distributed 2, completed. Don't take 3 in only on the first orbit. Only 2 electrons you have to take on the first orbit. What about other electrons? You need to distribute other electrons on other orbit. So the additional atom electron will be distributed or placed on the third orbit. Okay now in third orbit, how many electrons has to be there? Sorry, second orbit, how many electrons has to be there? 8. But how many are there? Only 1. That means this one electron has only one valency. It has to gain 7 electrons, or it has to lose 1 electrons. Gaining of 7 is much, so gaining of 7 electrons is much tough compared to losing this 1 electron. So lithium will become, valency will become 1. It will lose 1 electron and valency becomes 1. What about carbon? 6 electrons. Now distribute these 6 electrons. So in the second orbit you will have 4 only after distribution. But how many has to be there? 8 has to be there. That means 4 more electrons it is required to become stable. Okay now my dear children, 4 more electrons are required to become the stable in the second orbit. That means carbon valency will become 4. What about nitrogen? 7. So that means after distributing in the second orbit you will have 5 electrons. But how many electrons has to be there? 1 electron has to, 2 electrons has to be there. Okay now, like that nitrogen valency you will find. What about neon? That is 10. 2 electrons in the first shell, and 8 electrons will be distributed in the second shell. Okay now, 8 electrons will be distributed. As 8 is came in the second shell, it is satisfied the condition of 2n square elements, electrons. 2n square electrons condition is satisfied, so that is why neon valence is 0. Like this silicon we will see 14. So 2 electrons in the first orbit, 8 electrons in the second orbit, and 4 electrons in the third orbit we have distributed. But in third orbit, how many electrons? 18 electrons has to be there according to 2n square condition. But my dear children, we have to know one thing, that internally these orbits are divided. Okay, again internally these orbits are divided. From where? From third orbit onwards it is divided. That is, third orbit is divided into S and P. Okay, third shell is divided into 2 more orbits, that is S and P. Fourth shell is divided into 3 orbits, S, P, D. Okay now, division of this K shell, L shell, M shell and N shell is divided into S, SP, SPD, like that it is divided, my dear children. Okay now, internally it is divided. So that is why whenever we are talking about drawing on the paper, we just go for only 8 electrons. We will distribute 8 electrons in order to stabilize this. Okay now, we will show only 8 electrons. So we will take condition of 8 electrons only we will take. So in the outermost shell we have 4 electrons. How many more more are required to stabilize? 4 more are required. So that is why its stability is, in order to get stabilized, 4 more are required. So valence is 4 for silicon. What about chlorine? 17. Similarly we will distribute like this and its valency becomes 1. Okay now, I think you understood, but still we will see again this valency in order to understand much clearly. So first of all, what is valency? Combining capacity of an element with other atoms. Generally we are stabilizing. Valency is nothing but we have to stabilize the atom at any cost by losing or gaining the electrons. Okay now, see, take the example of again hydrogen. 1 electron hydrogen has 1 electron. Atomic number is 1 and it has it has 1 electron. Now distribute this 1 electron in the first orbit or first shell. What is valency? 1. That means one more electron has to be there in order to stabilize this hydrogen. But take the example of helium. Helium has 2 electrons. Its atomic number is 2. It has 2 electrons. So outermost shell electrons are nothing but valency electrons. We call it as valency electrons. Valency electrons of helium is 2 electrons. See, in blue dots I am showing you the electrons in the outermost orbit helium. It satisfied the condition, it's stabilized based on the condition 2n square, so its valence is 0. Like that, all neon, argon, krypton, xenon, all the inert gases are stabilized and their valence is 0. Okay now my dear children, now take the example of magnesium. Okay now, take the example of magnesium. So distribute its electrons. In the first orbit we have 2 electrons. In the second orbit we have 6, 7, 8, 9 electrons. 8 electrons we have distributed. In the third orbit we have distributed only 2 electrons. So that means in the third orbit how many electrons has to be there? 8 electrons has to be there. Okay now, actually as per the condition 2n square we need to have 18. Okay, but I told you 18 electron, third shell is divided into subdivided into 2 orbits like S and P. So in S you have 8 electrons, you have 8 electrons, like that. Okay now this is the case of magnesium. Take the example of fluorine. Okay now, in the first orbit we have 2. Take the case of second orbit. Distribute its electrons based on its atomic number, my dear children. Valency electrons is 7. You know, valency electrons means outermost, the electrons in the outermost shell. Okay now what is the valency? It has to gain 2 more electrons in the outermost orbit in order to gain stability. Okay now, in order to gain stability it has to acquire one more electron in the outermost orbit, one only now, so one more electron. Valency is 1. So why I am writing here F minus 1, that we will talk in the later. Okay now, fluorine is a non-metal. Generally all the non-metals, maximum non-metals, they will gain electrons and they will acquire negative charge. So here the valency of fluorine is 1. Okay now take the example. See here, HF CF4, that means okay now chlorine atom, carbon atom is being combined with the 4 fluorine atoms. Okay now my dear children, now take the example of oxygen. See, what is the atomic number of oxygen? 8. So distribute those 8 electrons in the orbits. First orbit you will have 2 electrons. In the second orbit you will have 6 electrons, so thereby 8 electrons distribution is completed. But in the outermost shell, what is valency electrons? Electrons in the outermost shell, that is 6. What about the valency of this oxygen? 2. So if it gains 2 electrons it becomes stabilized. Okay now, as it is a non-metal, it definitely acquires or gains the electrons from other atoms. So its valency definitely 2. Why? Because it gains electrons in the outermost orbit if it gains 2 electrons, it becomes stabilized. So valency of this oxygen atom is 2. Okay now my dear children, okay, see here why I am writing here 2 minus, we will see in the case further class. Okay, so take the example of, in the initial example I told you H2O, oxygen is being combined with 2 hydrogens. Oxygen needs 2 electrons, so it combined with 2 hydrogen atoms, CO2. Okay, oxygen is combined, 2 oxygen atoms are combining with 1 carbon atom. Like that also it can happen in order to stabilize. Okay now, this is about valency my dear children. Still valency is nothing but getting stabilized by combining with other atoms. Take the example of again sulfur. Okay now, so now distribute the electrons of sulfur based on its atomic number. So generally its atomic number is itself, it will be the number of electrons. So after distributing the electrons of sulfur on the, how many, what is the valency electrons you got? 6. Okay, valency electrons of sulfur is 6. That means the electrons in the outermost shell is 6. Okay now, what is the valency? That means my dear children, here we will see in the periodic table some elements will have variable valency. Okay now, some elements will have variable valency. Some elements will acquire electrons in order to get stabilized. Some elements will lose the electrons to get stabilized. Okay now, some elements will acquire the electrons, some elements will lose the electrons in order to get stabilized. So my dear children, here is, so those elements are having variable valency. So in this case, if sulfur loses all the 6 electrons in the outermost shell, it gets definitely stabilized. That means its valency is becoming 6. Okay na, valency is becoming 6 when it loses all the 6 electrons in the outermost orbit. Suppose if it acquires 2 electrons, okay na, if it acquires 2 electrons in the outermost shell, then it becoming stabilized by having 8 electrons in the outermost orbit. Okay na, in the outermost orbit always it has to be 8. Okay, 8 electrons has to be there. Now 8 electrons is there now in the outermost orbit. When it gains 2 electrons, yes. When it loses 6 electrons, is it get stabilized? Yes. Both cases it has. Okay, in the periodic table some elements has variable valency. Some will gain, some will lose. Some elements will what will do, some based on situations or based on the conditions, it will gain or it will lose. See, in the case of H2S, there sulfur is gaining 2 electrons from hydrogen, so that is why its valency became 2. Take the example of H2SO4. Here sulfur is giving the 6 electrons, so 4 electrons is being given to oxygen and 2 electrons is given to hydrogen by the sulfur. Like this my dear children, variable valency is happening in some elements. Okay, so in that variable, whenever the variable valency is happening, whenever in one case it will have low valency, in one case it will have high valency number. Okay, based on this valency numbers we are giving names to the elements. See here I am showing you the page on a textbook, page in the textbook. See, take the example of, so whenever for low valency numbers we will use add ous suffix. For higher valency number, the nomenclature or name of the element is given ic suffix. Okay, at the end of its name ic is added. See here example iron metal, that is ferrum. So it has variable valency. For low valency number the name given is ferrous. For higher valency number the name given is ferric. Like that copper, its cuprum is the Latin name. Okay now for lower valence it is cuprous, for higher valence it is cupric. Like this we will see argentinus, argentic, mercurus, mercuric. Like this we will see names of the elements having different valencies or variable valency. Children, I think you understood what is valency and variable valency. Okay now synopsis 2. In synopsis 2 we are studying about ions. Okay, what is ions? Okay, what is ions? Ions are nothing but an atom when it gained or loses electrons in the outermost shell, it acquires charge. Okay it acquires charge. Which charge is either it is positive or negative is based on the electron. When it gains it acquires negative charge, that is more electrons are there, so charge of electrons is more, that is negative charge it will acquire. Okay so ions, whenever an atom loses electrons from its valence shell or outermost orbit, it becomes positively charged and its name is given to it is cation. Cats are positive. Okay, you can remember in this way. What about when an atom gains electrons in the outermost orbit? It acquires negative charge. Okay, it becomes negative charged, so it is given a name called anions. Now take the example of sodium, my dear children, Na. In its valency in outermost shell there is one electron. Now whenever sodium loses this outermost shell electron, valency electron, so it becomes stabilized. So as it is lost, it becomes positively charged. I told you whenever an atom loses its electrons in the outermost orbit, it becomes positively charged, plus sodium ion, so plus ion is given. See how the charge is represented like this. Take the example of oxygen. You know oxygen atomic number is 8. In outermost electron orbit 6 electrons are there. So now this 6, if it wants to become stable, it has to gain 2 electrons. So as it is gaining electrons, it becomes negatively charged. Okay see here I am showing you sodium and oxygen. Till now we discussed. For negatively charged, gaining electrons 2 minus. For sodium, plus is given. Why? It is positively charged. What about the case of neon? As it is inert gas, it is stable. So it is a neutral. They don't acquire any charge. I am giving you a challenge, my dear children. You have to take the challenge for calcium. Okay you have to take the challenge for calcium and also chlorine. Not only these two, you have to practice in by taking other elements in from the periodic table. Okay, now here I am showing you calcium and chlorine. See, take the calcium, distribute the electrons based on its atomic number. So you will have, it acquires 2 electrons and it become Ca plus 2 ion. What about the chlorine? Okay, it loses 1 electron and becomes Cl minus. So base, what about argon? It is inert gas, so that is why it doesn't acquire any charge. See, write the structure like this. Okay na? Similarly, sodium and magnesium. See, my dear children, sodium and magnesium, all these are metals. Okay na? They are metals. So they, what I told you, metals will lose the electrons and they acquire positive charge. What about non-metals? What about non-metals? They will gain the electrons and acquire negative charge. So they are anions. So in group 6 you have oxygen. Oxygen is a non-metal. So in order to stabilize, it acquires 2 electrons in the outermost shell and acquires negative charge. It gains 2 electrons and acquires negative charge. Like that, in group 3 elements, aluminium, it is a metal. So as it is, aluminium is a metal, it loses electrons and acquires positive charge. Nitrogen, it is, see, nitrogen, carbon, these are all non-metals. What do non-metals do? They lose electrons and acquire negative charge. Okay, I think you understood what is anion, what is cation. Okay now, my dear children, I think you understood. I hope you understood what is ion. See, again ion is divided into subdivided. See, here I am showing you the page in the in the textbook, synopsis 2 page. See, types of ions we are studying. Types of ions in the sense, take the example of positive ion, that is positively charged ion. Cation, again in cation, suppose if an atom acquiring 2 electrons, it is divalent. So if an atom acquires 3 electrons, it is trivalent. Similarly, if an atom loses 4 electrons, it is tetravalent. 5 electrons, it is pentavalent. Like this, positive. See, here I am showing you, my dear children, cation, name of cations. So examples of monovalent. These are the examples of divalent: cupric, stannous, radium, Ra plus 2. For stannous, how it is denoted? Sn plus 2. See here, these are the examples of trivalent cations. Okay, ferric, Fe3 plus. That means they are losing 3 electrons. Okay, chromic, Cr3 plus. Boron means B3 plus. Now similarly, not for cations, for anions also it is there, division. The division is there like this, how many electrons it is gaining. So if an atom gains 1 electron, it is monovalent electronegative ion. If an atom gains 2 electrons, it is divalent. If an atom gains 3 electrons, it is trivalent. If it is 4 electrons, it is tetravalent. Okay now, my dear children, like this, ions are subdivided into tetra, tri, mono. Okay, like this. I think you understood based on what is valency. Okay, what is variable valency, and how the name is given based on variable valency, and what is ion, and which charge it is acquiring after becoming ion. Okay, thank you my dear children.